During low-carbon power production at the HECA plant, carbon dioxide, or CO2, is captured, compressed to a near liquid state, and transported via pipeline to the Oxy Elk Hills operation for enhanced oil recovery, or EOR, and sequestration. Extensive geological analysis has identified Oxy's Elk Hills field as one of the premier geologic traps in North America for enhanced oil recovery with permanent CO2 storage, due to its unique shape and secure geology. Millions of years ago, oil began migrating to the Elk Hills Reservoir, where the tiny pore spaces within the dome-like structure of the sandstone formation have retained the oil in place. The oil and gases have been contained underground by a thick, impermeable layer of shale or caprock, hundreds of feet thick, that forms a barrier naturally preventing fluids and gases from rising to the surface. Enhanced oil recovery with permanent CO2 sequestration or storage is a process where CO2 is injected into deep reservoirs to improve oil production, and is a technique already used in more than 100 U.S. oil field operations. CO2 will be transported from HECA to the Occidental Elk Hills operation, where enhanced oil recovery with permanent CO2 storage will be used to extend the life of Oxy's oil field. The CO2 is injected in a liquid-like state to a depth greater than 1 mile underground, the equivalent of 4 Empire State Buildings stacked one on top of the other. The CO2 travels down the wellbore to a precise and predetermined location within the rock formation that provides the greatest enhanced oil recovery and permanent CO2 storage benefit. As the CO2 mixes with the oil in the formation, the oil swells, reducing its viscosity, allowing the oil to flow more easily through the interconnected pore spaces towards the production well, which can result in 10 to 30% more oil production. During this process, the CO2 becomes trapped in the rock and is permanently stored in the pore spaces, in the same way oil was trapped in the formation millions of years ago, with the caprock serving as a physical barrier for the containment of the CO2. Other trapping mechanisms include the dissolution of CO2 in formation fluids and mineralization of the CO2 within the rock pore spaces. As fluids and gases are produced from the well, they flow through a series of vessels that separate them at Oxy's EOR plant. The oil is separated and stored in tanks prior to being delivered to the American market. A portion of the injected CO2 may be produced with the oil. This CO2 remains contained within the process system at all times and is immediately separated and combined with CO2 arriving from HECA for re-injection into the formation. This is known as a closed-loop process and ensures the injected CO2 is ultimately retained within the reservoir. Several methods will be employed to monitor, measure, and verify the containment of the CO2 in the formation 24 hours a day, 7 days a week. Sophisticated detection techniques and equipment are used in the reservoir and on the surface to ensure the accurate and safe storage of the CO2, the protection of underground sources of drinking water, and the public. In addition, the containment of CO2 in the target formation is further verified by the monitoring of CO2 levels in a gas production reservoir above the injection zone. Successful carbon capture and enhanced oil recovery with permanent CO2 storage in a project of this magnitude requires extensive skills, resources, and experience.